Hello everyone, welcome back to iBuddy, and today we're going to be doing lines of best fit and making predictions, which is part of Unit 6 in the Grade 9 math curriculum. Now our learning goal today is to be able to demonstrate how to draw a line of best fit, interpolate, and extrapolate. These are very important concepts that you'll likely be using in your math IA if you're an IB student. Otherwise, they're also very good important mathematical concepts that are important later on in your career. Now, the first thing we're going to start off with is a warm-up. Here we have a graph that represents the relationship between earnings and the time worked. Now, it's asking us which point represents the person who worked the least amount of hours. If we look at our graph, we can determine that it is M. It is M because they only worked 2 hours, which is evident as it's the lowest in this variable right here. Now it's asking us which point represents the person who earned the most amount of money. We can tell that this is probably P because they are the highest in the earnings. There's no one else that's really below them. For example, in 70, it's only N, M for 40, same as Q. So P made the most amount of money since it's the highest in this variable, which is 80. So P would be $80. Which point represents the person who has the highest rate of pay? Now this one is a little bit more difficult, and we're going to need a little bit more calculations for this. In this case, what we can do is take the slope. So M, we're going to do, they make $40, and they do it in 2 hours. So we can get a rate of change here, which will be equal to $1.20 an hour. Then we can also check Q. Q is 40 because they make $40. And then we can divide it by 8. So they make $5 an hour. Then N. N is 70 divided by 4. So they make $17.5 an hour. We also have our point of 80 over 7, which would be P. This is because P makes $80 and they have 7 hours of work. So P is 80 over 7, which is approximately $11.43 an hour. If we just look at all these prices, we can immediately tell that the highest rate of pay is $20 an hour. This one gets a little bit close, and this one's the lowest rate of pay. Now here's the part where we have a graph that relates bus passengers with number of passengers and the hours driven. It's asking us how many hours were driven when 40 passengers were on the bus. So let's go here. We see that it's 40. We connect it until we reach approximately here, where there's a point right here. It goes down. So that would be 16 hours. Next, it's asking us how many passengers were on the bus after 10 hours of driving. If we look at 10 hours, which is right here, we can see that it doesn't actually equate to any point. So it's none. How many passengers were aboard this bus after 6 hours of driving? Is this answer realistic? Why or why not? Now after 6 hours of driving, it's right here. And this is not really realistic because people could be getting on and off the bus, so it doesn't really make any sense. Also, there's nothing here. Can you determine how many passengers were driven or abroad after 26 hours? Why or why not? And I'm just going to say no. The reason why is because, well, there's nothing here. There are no points. So for our next piece, we're going to be making predictions from data. Now, if we see this, we have two variables. We have initial height and speed. Our independent variable here, which is initial height. And this is the independent variable because the value does not depend on speed. Now, our dependent variable is speed itself. And this is a dependent variable because this value increases or decreases depending on the initial height. The key phrase right here is depending on initial height. Now here it's asking us to make a scatter plot, which I won't be doing. It's already done here. And it's asking us to describe the relationship between it. So I'm going to say, first of all, this relationship is linear. It is a positive relationship. And I'm gonna quickly describe it because as the initial height increases, the speed increases. So now we're gonna need to identify outliers, and we need to see what might cause an outlier. So in this case, we can determine that there's most of these points are on this line pretty well, but there is this one point that's kind of like right here, and so I'm gonna identify this outlier real quick. So here it is. We're gonna relate it right here. We're gonna quickly identify the outlier as 4 and 4.5. And what we're gonna say basically is that it's basically, if we think about it, it could be caused by someone slowing down due to fear. So let's write that right here. This is honestly because of this, as our initial word problem was talking about a skateboarder and a steep ramp. So now it's asking us to draw a line that passes close to the data points. How many data points are on the line, how many are above, and how many are below. In this case, it's kind of difficult to determine it, but as you can see here, we have these two, which is 2 points that are on it. You can see that there's like around 3 that are above it. And 3 points below it. In this case, we screw the outlier because that guy's just scared. Now we need to compare this line with 2 other students' line. And really, they shouldn't be the exact same. And that's probably because this is an estimate. They will be similar though. Now using the line we drew, we need to predict the speed of the skateboarder at an initial height of 1 meter. So we didn't really draw it, they put it for us. But at 1 meter, it's around here. So that's about 3.5 kilometers. Sorry, 3.5 meters per second. Now, will there be any other students in the class that get the same exact answer as G? Why or why not? Since our lines aren't really the same, the answers to G will be slightly different. So this basically goes upon our point over here anyways. So now, we're gonna do some more line of best fit. I kind of want to talk right here. We're gonna do some definitions. So how you get the line of best fit? Well, the line, first of all, must follow the trend, the overall trend of it. The line should pass through as many points as possible. There should be the same number of points above and below the line. The line should pass through the points all along the line, not just at the ends. And the line must be drawn with a ruler. That's specifically important because little tiny imperfections, like doing something like that, could completely change the result. And we need to be as precise as possible. Here you have an outlier that we've already talked about from before. So now let's talk a little bit about interpolation and extrapolation. So when you interpolate, now what this basically means is you're going from inside the data, you're making predictions within the data. So these predictions are usually fairly accurate, but it's with the opposite with extrapolate. When you interpolate, you're doing predictions outside the data. Sorry, I think this is a typo. It's supposed to be extrapolate here. So this often requires you to extend the line. And these tend to be less accurate to your scenario. So here, for example, we have lines of best fit, and we need to get an answer to it. So what do you guys think a student's mark will be if they study for 4 hours? In my opinion, I say about 80%. And this method would probably be interpolating. Now, of course, we're going back here. This is essentially right here where we have a test score and we have our results. So if a student studied for 4 hours, they would get about a 75. That would be interpolating because we're inside it. Now, if a student mark, if they did not study, let's go back. If they did not study, that means they would have 0 hours, and we can determine that that is not really within any of these points, so that would be extrapolating, but we can see that it's 50. How long would a student study if they got 60%? Well, you have 60% right here, and that is around 1.5 hours. So we're going to write that. And that would be interpolating, because we are inside the data. And then we need to check how long a student would study if they received an 100. This one is a little bit more difficult. 100 is around here. So this would be extrapolating, but that would be around 8 hours. Or in our case, we have 8. And that would be extrapolating because it's outside the data set. Now, here we have another example. Melia works at it and records the number of ice cream cones she sells each day and the maximum daily temperature as shown on the graph below. According to this graph, approximately how many ice cream cones will Melia sell on a day when the maximum temperature is 83 Fahrenheit? Justify your answer. Well, first thing we can see is that Melia would sell probably 40 cones, and we know this because if we look at the line of best fit, we've drawn a line of 40 to 82 Fahrenheit. This is around 83 actually. So that would be approximately 40. We know this by looking at the line of the best fit. Deshawn is a marine biologist and has been studying a small population of sharks that reside in a bay off the coast of Australia. He collects the following data and creates a scatter plot. Which point represents a shark size that's not following the trend? You can see here that that's kind of an outlier. So we can attribute that to 15, around 15, 300. Deshawn was able to measure the length of a shark to be 250 centimeters. How much should he expect the shark to weigh? And I would say approximately 80 kilograms. And that's because when we look here, minus 250 centimeters, it really is an interpolation, and we can determine that it's around here, so it's about 80 kilograms. So now I'm going to be looking to here. So this is just another example that you guys can look. It's basically just plotting the data on the scatter plot and then doing some questions. So in this case, the symbol is this symbol right here. It's used to signal a break in the axis when the scale does not start at 0 to avoid a large empty space in one corner of the graph. This is important in specifically IAs when you don't have values that are lower on the graph. Even I use this too. This little marking here, it's pretty important. Now, another thing that we have to understand here is that our line of best fit is like this. There's the same amount of points above and below. There's also points inside, has many points inside the line. And if we predict the earnings of a 29-year-old, if we look right here, it's about $26. Now this is in thousands, so we convert it to $26,000. It's interpolation because it's inside the data scale rather than being outside or outside. To predict the earnings of an 80-year-old. Now, an 80-year-old is around here. This goes above our data, so this is extrapolation, and it would be around 52,000 because when we go here, it hits 52 and it's in thousands. Explain why the data ages over 65 do not follow the data. And yeah, another feeling about this would probably be retirement. And they're specifically talking about these ones. Now all we have for today's lesson is a little bit more simple. There's some worksheets that are attached just in case you didn't get the lesson as much. But of course this one's a little bit more simpler compared to the others. And I hope you do the worksheets and try some practice problems. Bye.